Okay, we are going to do a function activity that is a very concrete way to understand whether a set of ordered pairs called a relation is going to be a function or whether it's not a function. So for this activity, you're going to be working with your shoulder partner. Each of you need to choose 2 ordered pairs, so a total of 4 ordered pairs. You each need to write your ordered pairs on the whiteboard and then plot them on the whiteboard graph. So you're going to write 2 ordered pairs and plot 2 ordered pairs. The numbers for those ordered pairs need to be between 0 and 10, so they'll fit on the 0 and 10, 0 and negative 10, so they'll fit on the graph. When you're finished, you're going to be answering the following questions for your data. What is the domain? What is the range? Whether or not your relation is a function, and the reason that it's a function or not a function. We're also going to be trying to determine other ways of figuring out whether a relation is a function that don't involve graphing. So that will be something we'll consider at the very end. So right now, choose those pairs, get them graphed, and we'll be starting. If you're an absent student, pick your pairs, get them plotted, then turn the recording back on. Okay, I'm going to give you a little example of how to do this using my ordered pairs, 0, 2, 2, negative 1, 4, 2, and 2, 5. So we're going to plot 0, 2, 2, negative 1, 4, 2, and 2, 5. You don't need to write those ordered pairs on the graph. You just need to plot them. Now, we're going to use what we call a vertical line test. A vertical line test is not a concept. It is simply a tool in order to make some determinations about whether a relation, set of ordered pairs is a relation, is a function or not. So the test is just like it sounds, a vertical line. You draw a vertical line through each of the points. It doesn't have to be very long. It just has to go through the points. Okay, so as you can see, all of my points have a line through them. And on the first line and the third line, you can see that there's a single point on that line. So those two are fine. Where we're not fine and where this is not a function is that for the second, that middle line, there's 2 points on it, and there can only be 1. So because the vertical line has 2 points on it, it does not meet the formal definition of a function, and I'll get to that in just a moment, and therefore it is not a function. So we're going to write the relation, or I'm going to write, you're not, is not a function because, and we're not going to write that there are two ordered pairs on the same vertical line. It's a test, but it's not the real reason. We're going to get into that real reason very shortly. So why don't you go ahead and put vertical lines through your 4 points and make the determination of whether it is a relation or it's not whether it is a function or not a function, and write that down, and then start up the video again if you're an absent student. Mathematics has quite a language of its own, and in order to be able to do many things competently in mathematics, you have to understand its language. So one of the things, we talked about relation already. Relation is just a group of, a set of ordered pairs, and where you're matching up x's with y's. The domain of that relation is, in my case, 0, the x values, 2, 4, and 2. I'm not going to write that 2 twice. All I'm going to do is write it 1 time, and I'm also going to put it in numerical order. Although that's not necessary, I'm going to go ahead and do that. So we have 0, 2, 4. That is the domain of my relation. Now my range are all my output values, which are 2. These are my y values, negative 1, 2 again, and 5. I'm not going to write that 2 twice. I'm just going to write negative 1, 2, and 5. It's just coincidental that the y values have a repeating 2 as well. All right, now I've written the domain, I've written the range. We are going to be using this idea of the x values, the input values for the domain. So domain are input and x values, whereas range are output and y values. Just to give you some more language to help you with this. We are going to put these in a input-output table. Most of the time, input-output tables are either horizontal. And if you look at your page 67 in your book through page 69, so it's page 67 through 69, you'll see a lot of this. So they can be horizontal, but I prefer them vertically. So you can have them either horizontally or vertically. And you simply write your ordered pairs, x coordinates 0, output, or y coordinates 2, x coordinates 2, output, or y coordinates -1, x coordinates 4, y coordinates 2, and x on the final ordered pair, x coordinates 2 and y coordinates 5. Go ahead and pause right now, get that written down on your own piece of paper for your own problem, and then restart the video again if you were an absent student. Now, if we were only determining whether or not something was a function or not, you will, in testing and worksheet situations, and in fact, on page 67 in your text, you will see what is kind of odd, an odd way of showing this. This is more typical, either this way that I'm going around in a circle, this vertical, let me go with this other thing, this way, or a horizontal table, which is on page 69, is a much more typical way of showing an input-output table. But on page 67, and I've seen them elsewhere, you will see input and output tables that look like this. Very strange looking. So our domain values, our input values are 0, 2, 4. Our output or y values are -1, 2, 5. And then they simply draw arrows. So your first ordered pair was 0, 2, so 0 goes with 2. Your second one is 2, -1, so 2 goes with -1. So far, we have an x value with a single y value. Then we go 4, 2. Okay, now what we're seeing is we've got the input of 0 and the input of 4 with 2. But that's okay, because we have 0, 2 and 4, 2. That's not a problem because it's not it's not giving us multiple points on a vertical line. So that one's going to be okay. Here's the one that's not going to be okay. This 2, this x value, this input value, not only goes to -1, it goes to 5. That's not going to be okay because when you have an input value, an x value with more than one output, then you are going to end up not having a function. So I want you to go through and look at your data and make a determination of how you would decide whether a relation, a set of ordered pairs, is in fact a function or it is not a function. So if I were just to look at these points, if I were just to look at these points, could I know whether or not it was a relation? Let's go ahead and write the formal or I'll say the formal definition, then I'll use it as part of this. The formal definition of a function is for every input, there is exactly one output. So let's go ahead and write that. So function. I'm going to go ahead and pause it while I write it, and then we'll read it again. So for a function, for a relation to be a function, remember a relation is a set of ordered pairs. For a relation to be a function, every input has exactly one output. So if you look at mine, I have this input of 2, so there's an x of 2 and another x of 2, but it doesn't just have one output, it has two outputs. It has -1 and 5. So for me, in my set of data, my relation is not a function because there is more than one output for each input. Now, it didn't matter, and this is important, it didn't matter that there were multiple inputs for the output. So for instance, it was okay that we had 0, 2, so 0 had an output of 2, and 4, 2. Even though they're in a horizontal line, that does not affect whether they're a function or not. So it's only repeats in your inputs or your x's that cause you to have more than one output for every input. It does not matter if you have a repeat in your outputs or your y values. Go ahead and finish your activity up. If you've been absent, make sure you turn your worksheet in to me. All students who are in class have received full credit for this activity. Thank you.